In my definition, does anyone recall there was a restriction on what x can be in order for a log to exist? Does anyone remember what the domain is on a log? The x must be greater than 0. Cannot even be equal to 0. It's going to be greater than 0. A is the base. There's a restriction on the A. A had to be greater than 0, but please do not let A be 1. All in the definition. Now that said, I thought, hold on. Before I jump into some examples, go back, I'd like to in part B show what a sketch looks like of f of x is equal to, let's try guys, I'm going to try 2 raised to, no, log base 2 x. Let's make it a function, and now see what the graph looks like for a log. Guys, some students may recognize right quickly without going through much detail. Does anyone think they know what a basic graph of log base 2 of x may look like? A log graph, just basic log graph. Sketch. Log, I'm trying log base 2x. Does anyone recognize what a log graph is? It's not a parabola, it's not a circle, it's not a straight line. There's a certain parent graph for a log. Guys, the x-intercept should always be what? 1. And the graph itself, I'll look like this. And this is a basic graph of, I'm using log base 2, log base A of x. That's what a log graph looks like. And by the way, please tell me, if you look at the graph itself, if I accept this as a graph for log, what's my domain on this graph? From left to right, how would you describe the graph itself? Is there anything to the left of 0? Where 0 is right here. Is there any part of that graph to the left? No, it's all to the right of 0, which says x must be greater than 0 to the right. Or we'll put this in interval notation. You write like that, and that agrees with the definition. The definition says it should be greater than 0. So far, so good. Range, if I ask for the range is a giveaway. The up and down, the y values, it drops down forever, rises forever. So negative infinity through a positive infinity. And that's just a basic graph. Now, with all that said, let's see if I'm ready for something here. I think I am. Letter C. My 4 o'clock session, and I think I brought some in. I thought maybe some students would be asking some questions here. Yes, I did bring some in. I've got my notes here. Oh, I did. Here we go. Let's try to find the value for it. We'll call it evaluate. Find the value. A little recap here. I'd like to find the value for these if we can. Log base square root 3, 1 over 27. Number 2, ln square root e. Number 3, log base 1/4 16. Let's get a sense of what that means. Those are all logs. They're asking for evaluation, no calculators. So you have to know what those statements, when you look at them, mean. Guys, the first one, I'm going to translate it. Can someone first translate for me? Here's my definition. So what would, if I follow this definition, what would that log base radical 3, 1 over 27, what would that look like translated? Anyone? What does it mean? Right out here.
Radical 3x equals 1 over 27.
Here we go.
Radical 3 to the power of x.
Radical 3 raised to something, think is equal to, let's go ahead and call this for right now. 1 over 27. That's what it means. Now, Isabella's being clever here. She said, wait, Professor, I'd like to have those two sides, if possible, in terms of a common base. Now here, be careful guys. I'm going to use a common base of 3. We'll rewrite each side in terms of a 3. Square root 3 can be written as 3 raised to the 1/2. And of course I got an X up there with it. The 1/27 can be written in terms of base 3 as what? Help me out, guys.
Negative.
3, thank you, raised to a -3. Okay, so I've got the two sides in terms of a common base. If I do, then this must be equal to that. You guys, if I set my 1/2 X equal to a -3, I'm careful, solve this, I think it's an 86. And therefore, what's the log of 1/27 base radical 3? It is, if there's no mistake, -6. Next one says ln of square root e. Can someone first tell me on the side here, what might it look like? What's it mean? And this is a natural logarithm. ln understood to be a base what? E. Now can someone, e's not written, guys. You can squeeze it in yourself if you wish. It's right there. Anyone tell me what that means? And then we'll find the answer.
E to the power of x equals.
Absolutely. E raised to some power will give me square root e. That's from that definition on the side here. I would like to write this square root e, if you don't mind, as e raised to the 1/2. We're saying the same thing. That's square root e. And guys, with that right there, I see directly. To make the statement true, x must be equal to what? 1/2. So this is the answer for ln square root e. No problem. Next one says, looks strange on my number 3, that says log base 1/4 of 16. It means, Isabella, tell the class what it means.
1/4 to the power of x equals 16.
Love it. That's exactly what it means. I'm gonna give you partial credit for just telling first what it means. Now, it's going to come up with a common base for those two sides. And I'll rewrite. And I see a couple of possibilities here of a common base. Does anyone have a common base in mind that I can rewrite for two sides? Can we get 4? Let's try 4. Now, if you try 4, what would 1/4, if I'm trying base 4, what would 1/4 look like? Yeah, I got 4 raised to a -1. And guys, that's the same as 1/4. And of course, the x is still there. There you go, -x won't be a -x. And the 16 is a little bit easier. I'm going to use her base 4 she suggested. This is merely what? 4 squared. Now we've got both sides in terms of a common base. Therefore, for this statement to be true, this must be equal to this. I got -x is equal to 2. X is equal to -2 if there's no mistake. Therefore, that's the answer for log 16 base 1/4. Now, before I leave this one, just a little translation of what it means. Can anyone tell me another base I could have used besides 4? And sometimes you have an option. Is there another base that you could have used besides her 4 she suggested? 2. Try 2 here, guys. 1/4, be very careful. Does anyone know what 1/4 looks like using base 2? I heard 2 raised to what? -2. That's 1/4. Of course, the x is still up there. 2 raised to a -2 is the same as 1/4, believe it or not. 16 base 2, that's a little bit easier. That's 2 to the 4th. And therefore, I've got the two sides in terms of a common base. Therefore, these must be equal. And guys, when I set -2x equal to 4, got to get away here. I think we'll end up with x is equal to a -2 again. Is that true? That's just a mere translation of what a log looks like. We have a log graph on the side there. You got the domain business going on. Now, I will point out, and we'll get to it shortly here, if. Aaron, I want to ask you a question here. Number 4, let's put it in a different color. Aaron, suppose I'll ask you this. Log base 3, 28. And you may look at it and say, Professor, it's a Monday, you must be a little tired. Why don't you put a 27, Professor? I think this wrote down wrong, Professor, a little tired. If that had said 27, log of 27 base 3 is a giveaway. What is it? It's 3. 3 cubed. Is that true? I give you a 28. Aaron, can you tell the class though, first, what does it mean? Translate it for us.
3 to the power of x equals 28.
3 raised to the power of x, absolute, is equal to 28. Good luck. I did not give you nice, well-behaved numbers like I did them here. Now, can this happen? This can happen. This can happen. Anyone tell me the best you could? We can't get an exact answer unless I turn to a calculator. Anyone tell me what? Okay, here we go. Maybe what I could do? Anything at all? If that had been a 27, you'd be finished. This is 28. He translated this thing perfectly for me. That's what it means. Can anyone give me some type of response? Anything at all that you can say about this at this time?
Can we split like 27 plus 1?
Do it again now. Oh, got you. So, guys, you want to write this what? 27 plus 1, which is 28. And, I'm seeing you trying to get clever here. 3 raised to the x. I like that. And why not? We'll try it. That's still 28, right? But what do you want to do from there?
3 power of 3.
Yeah, I see it. 3 is going to maybe in your head there because 3 cubed is 27, right?
Plus 3 and 0.
Or with a decimal? Maybe with a decimal to work with? Guys, is it going to be 3 point something? Now, what is that point something? I don't know. I don't know myself. It's 3 point something at this point. That's the one that I just cannot do. Mark, can you find real quickly what the log of 28 base 3 is? Mr. Berkeley? Tell us what it's close to?
Yeah. 3.03.
Oh, 3.03. Now, would I have known that just looking at this? No. I would not have known it myself. And guys, some of these you'll run into that you just can't do much with. So I thought I'd throw that in and we'll look at something with this later on. Guys, any concerns? My concern was on a Monday, since I hadn't seen you for a while. Now I hear some of my students may have forgotten what this meant. They've forgotten what the log graph looks like. Oh, wait, before I leave that grid, suppose I ask you to graph, since I have the grid there, along with, this is log, guys. I like to graph now, this was log of x base 2. Suppose I use a different color. Suppose now I ask you to graph on the same grid. G of x is not a log, it's an exponential. What does 2 raised to the x look like? Y-intercept now is up here at 1. And does it take off and do something like this? Is that true, guys? Does it look something like that? And can you tell me, please tell me, Brianna? She's not here with us yet. No. She always tells me, guys, if I draw a reflecting line, I think it's y is equal to x. Squeeze that in. Does that black graph and the green graph look like they may be reflections of one another across that line? We looked at that last week. Are those two inverses of one another? The exponential and the log are the inverses. Now, before I leave all this beautiful work here on the side here, before I move on, so let's write this down, guys. So f of x is equal to log base 2x, and g of x is equal to 2 raised to the x. I have you green over there. We are going to consider these two as inverses, inverse functions. Now, can anyone tell me on this Monday, if they are inverse functions, what can I say? There's lots of things I can say about those two functions. They are now inverses. What can I say?
The main equals the range.
Oh, I love that, love that. The domain of the inverse should be the range of the original. Love it. And the range, absolutely, of that inverse should correspond to the domain of the original. Critical. Okay, can anyone tell me anything else that could be said about those two? It's an exponential with a log, and these two are considered to be inverses. Anything else that you recall from last week that I could say? Does anyone remember?
1 to 1.
Okay, they're inverses, both functions should be what, 1 to 1? Should be a 1 to 1 function with, and by the way, since I graph at least the log, I graph both of them. The green one, you use the horizontal line test, you pass the horizontal line test. The black one, pass the horizontal line, pass the horizontal line test. So they're both 1 to 1. So they have inverses, and we think they are inverses of one another. Something else a little bit more critical. What is it? I have some examples to bring in at the jump. One more item there I'd like to hear someone tell me about this. You want to see it? What else did we do last week? Yes, there we go.
You plug them, like you plug g of x back into fx and see if it equals f.
And what's that called? That's called what? Forming a composite? So if we form a composite of the function with its inverse, the guys, I got f and g, so you write it like this, f with g, like this is what everybody else talking about. She says, Professor, when you do that, you should get x. In fact, I think I use this for a check, see if I did have the correct inverse. Or turn it around, g with f of x should also be x. Is that true? Now, if I do it, let me do it in this order. With some help from you guys here. If I do it in this order, and Abigail again, this says f of g of x. So she's telling me, Professor, that says, in that first one, the way it's written, go back, put your g of x into the f of x. If I do, guys, the g of x placed into the f of x, does it look like this? Log base 2 of 2 raised to the x. Is that the g of x taken back into the f? Now, what's that supposed to be equal to? Since these two functions are inverses, it does not always work unless they're inverses. Since they are inverses, what should it be equal to? X. Just mere x. If those two have been identified as inverses. Now, can someone tell me from last week, how could I go a little further and show, Professor, it is x? Log base 2 of 2 raised to the x, Professor, is merely x. I know the statement on the side says it should be, and it should. But can you tell me another reason from last week that maybe would verify, yeah, it's x? Anyone recall? Leads me into another piece of chapter 4 and closing down. What was it? Did we have some properties for logs? Did we have a product property, quotient property, power property? Now, look at this. If this is being raised to a power, if I'm going to go back and apply the power property for this log, move the x out front, and rewrite this as x log base 2 of 2. That's power property. Then at the same time, if I take a close look at this piece of it, guys, what is log of 2 base 2? 1. 2 raised to the 1 is 2. So this says x times 1, and here's another verification, it's going to be x. This statement says it's x, now verified by doing this other power property, it is x. Okay, now if I do it in the other direction, this one's done. This one down here, guys, put down here. Now in this order it says place F into G. Now this one's gonna look strange. 2 raised to log base 2x. That's placing F into G. Looks strange, but what must the answer be? Yes. That is one of the most powerful statements. And I see so many students making mistakes. Now guys, I have mine in base 2. So if you saw this, 5 raised to log base 5, 40. What's the answer? What's the answer have to be? Even though it looks so strange. 5 raised to log base 5 to 40. I made these two match up. And therefore what? The answer is what? X. And X in this case is what? 40. If these two match up. If they don't match up, we have issues. So we're using one of these properties along with something like that. So I thought I'd point that out. Also, now let's see something else I need to point out. I do. Now, all this is a recap before I get to the end of the chapter here. Did I bring that in? I think I did. I did. Here we go. I'd love for a student to give me a response on this. I'd like to find the value for this. 10 raised to 3 log 2 subtract log 4. A little recap here. Oh, by the way, I noticed I did not put my subscript in there. Is this a base 2? Is it a base 5? Is it a base 4? I did not put my subscript in. Now, if the subscript is missing, it's understood to be a base, always 10. So if you think they made a mistake, or I made a mistake as a professor, you forgot to put the little subscript in here. Is it log base 2, log base 3, log base 4? If it's missing, it's understood to be a 10. It's called a common logarithm. And many times they will do that in the textbook. They'll say, oh, they made a mistake. What base was it? It's understood to be a 10, called a common logarithm. Now, though, I like to find the answer. I'm trying to relate it to this over here. Does anyone have an idea? It's a beautiful problem. Beautiful problem. Oh, you think the final answer is 2. Michael says he thinks the final answer is 2.
2 divided by 4?
Now 2 divided by 4, that would be 1/2. So there's another possibility. It could be 1/2, it could be a 2. Any other possibilities? Now, can someone tell me, to set this up, I'm concerned about first.
Oh, see, you have to
Get close, get close. You got to first deal with all of that. That's your exponent up there. And to deal with that, you're going to use the properties. Now, please help me out. I think, can we use power property to start out with here? Could I move this 3 up there back into a power? And what does that subtraction sign indicate also is taking place? A division. So all that together with the help of the properties, I can rewrite this as one single log, 10 raised to log, I'm still be a base 10 here, guys. What's that? 2 cubed over 4. Is that it written all together? 2 cubed over 4. Got a quotient going on, got a power going on. Or, better yet, it says 10 raised to log of, 2 cubed is 8. 8 divided by 4 is what, 2? And keep in mind, guys, if it's not written, it's understood to be a 10 there. Common logarithm. Do I have what I need? Do these match up, which I need? And therefore, is the answer 2? After all that work. you getting? Michael, were you thinking sort of along that line, or, were you, okay? Mr. Park,
Mm-hmm.
I want you to check something else for me. Would you check this, like this, I gave him originally this, can you put that into whatever device you're using?
Mm-hmm.
Can you put it in the original like this?
Yeah.
10 raised to all that business? And we're thinking for the properties, the answer is 2. See if it is.
Yeah.
It is?
Mm-hmm.
Checks out. Absolutely. Now, I have another one similar to that before I move on. And that was here. 1, 2, we tried an example there, 3, let's call it. Got another example, guys. Got examples all over the board here. Let me put this one in a different color here. E raised to 3 ln 2 subtract 2 ln 3. Oh, this is cute. This is cute. By the way, you see that ln notation is understood to be a base E, the E is not written, it's called a natural log. Now, can I rewrite, as I did the previous problem, can I rewrite, with the help of the properties, all of that in that exponents place? Much like I think you saw me do up there. I could move the 3 back up here as a power, use power property. The 2 back up here as power property again, on the second term. And the subtraction sign says express this as a what? Quotient. Altogether expressed as ln of 2 cubed over 3 squared. Better yet, E raised to ln, guys, looks like it's 8 over 9. Now, what can I say? What must the answer be? 8 ninths. 8 ninths. My bases match up. That should be an E for that natural logarithm. So the answer after all that work is merely 8 over 9. Done. With the help of the properties, with the help of the definition, so forth and so on. Let me check and see if I'm ready for this. Oh, I am. Last one. Am I ready? I'm getting a little scared. Okay. Let's put this on the side here, another example. 4 raised to log base 16, 300. Okay. It's going to be a challenge. Anyone think they know what this one is? Does anyone think they know what the answer? Michael gave you this one back up here, I think it was. The professor's 2. Now I heard also maybe a 1/2 earlier. I can see why that 2 or 1/2 came out. Does anyone see anything coming out here on this crazy thing? The top part says, the exponent says log of 300 base 16. Good luck, guys. I can't think of myself. 16 raised to what power will give me 300? That's what it's asking. 16 raised to what power? There's no nice power to work with. So what's going on here? Yeah, it is. It's a little challenge problem. By the way, are these close to being the same? I got 4 and a 16. I could rewrite that 16 as 4 squared. I could if I wish. There's nothing wrong with that. At least I have a 4, but are they exactly the same? No, I got a 4 and I got a 4 here, but it's 4 squared. They're supposed to be identical. Should be 4 and 4. 4 and 4, not 4 and 4 squared, even though there is a relationship going on here. Does anyone have an idea what the answer might be? You want to look at it? Make it off.
So we'll make it 16 instead of 4?
Figure it out?
So we'll make 16 instead of 4? First one.
Okay, tell me what you think the final answer is. Tell me what you think the final answer is. I think I'll be shocked. This is the toughest one. Where the bases do not match. They come close to matching, but they're not the same. Got to move something right here. I'm going to focus on this. To get some input from you guys. I gotta watch it. I'm trying to put this chapter down. On the side here, what bothers me is log of 16 of 300. Whoa, I'm trying to think of a good way to do this. Equals something. That's what it says there. Log of 300 base 16 equals x, it's called. Which now might mean 16 raised to the x is equal to 300. Is that true? That's what it means. Still though, I cannot write each side in terms of a common base like some of these others. Which you can. I cannot use a common base. Now here's the issue. You could, and I don't have Park help me, you could, when a situation like this happens, you could say, Professor, can I go ahead and introduce a log, as long as I do it on both sides? On both sides. I can take a log on both sides. For a reason here. If I do, on the left-hand side, I could use power properties, and wait, now, if you want to do that, why not rewrite it as x placed out front, power property, log of 16, and equal to log of 300. Solve for x, divide through by, log of 16. It looks like it's going to get crazier on me. But it looks like it might look like that at this point, which is not looking good. But does that logic make sense? I could express it as log of 300 over log of 16. Now, I don't know what log of 300 is myself. Log of 16, if there were a base 2, I'd quickly say 4. But it's understood to be a base 10 on this. Oh, boy. Went backwards to base. Yeah, I put a base 10 there. Oh, wow, guys, are we stuck? Are we stuck? Someone help me.
Can the answer be the
Square
square root of 300?
root 300 is the answer. I want to know a rationale why.
If we do like 16 instead of 4, means it's 16 in
Oh, you're back here?
power of one half.
Right here?
No, instead of 4.
Oh, you want to put a 1/2.
Yeah.
1/2 raised to the -4?
The first one where the
Oh, right
4
here.
is 16,
Yeah?
and we do
Oh, right here, right here.
And we do 1/2 log.
She's got a 1/2 in mind, and there's a 1/2 involved here. And her answer, square root 300, which could be simplified, works out. Now I'm trying to get to a rationale. Why is it working? Why is it, Professor? Why is the answer to this mess? And she's telling me the answer. Why is it square root 300, or better yet, break it down, 10 radical 3. 100 times 3. Why is that true, Professor?
So we do 16 in power of 1/2 log 16 300. So it's going to be the same base 16 and 16.
Okay, now you're trying to get me to write something in terms of the base 1/2. Right?
same base is gonna be 16.
Yeah, oh, the base is going to be 16, okay, I got you. And you want me to write 16, going back up here, 16,
And here 16, and log half, log 16.
oh, back here, this 16 raised to 1/2?
Yes.
She wants me to rewrite 4 out front of 16 raised to 1/2. Is that 4? Is 16, which means square root 16? Oh, wait, I'm gonna follow her logic. Hang on, she's a professor. Rewrite this as that. True?
Yes.
I love that. Now, you got 1/2 there, and now you're saying this is, help me out, log base 16, 300.
Which means it's log 16 to
Look at
100
this,
squared.
look at this. And then power problem says, wait, Professor, you could bring that 1/2 she gave you up there and rewrite this as 16 raised to log base 16, 3. Clever, clever, clever. Power problem. Genius. Thank you so much. Now, do we have the same base now? It's her help. And therefore the answer should be 300 raised to 1/2, which is square root 300. And sure enough, I went ahead and broke this down into 10 square root, what was it, guys, 3? In that form. And she is correct. So there was some way to rewrite in terms of a common base. Thank you, thank you. A long time, one of my classes where a student gave me that idea. To rewrite, professor, rewrite this 4 as 16 raised to 1/2. Nice. Guys, you follow her logic? Okay. Now, I've got the board full. And like I said, I'm trying to close this chapter down. Guys, look at it. Please look at it. The quiz on Wednesday is 4344. 43 is the exponentials. 44 is the section on logarithms. That's all you're responsible for on Wednesday. I think we're doing a pretty good job in closing this down, because this is one of the toughest chapters in the textbook. It's chapter 4 for students, the logarithms to work with. Okay, let's see how much more I have to do here. Michael, we'll give some handouts here shortly. Oh, yes. Another item here. I got all carried away there, guys. I got all done in part 1, I guess. Let's call this part 2. I like to sketch this. Closing this chapter down for sure. I brought in this one. F of x is equal to, got a negative sign stuck out front, log, try base 2 again, of this, and then subtract 3. Now, if I'm not mistaken, you could have one like that on quiz Wednesday. I think it's either in, I think it's 4.4. Okay, guys, let's do it through transformations. Now, you guys were with me at 4 o'clock. You saw a lot of this. We were doing a lot of this business with transformations. Guys, here goes. Michael, remind me, since you were asking about this in the 4 o'clock session, this is not the same problem, is it? No. Okay. It must be a different problem. Let me get this thing set up here. Here we go. Now, you know, if I say use transformations, which I will ask for transformations, I need first a parent graph. Just a basic, in this case, log graph. If you say, Professor, can I use this? Of course you can. You have to write this as representing log base 2 x. If this were ln, use the same sketch. Log base 3, use the same sketch for your parent graph. Now, let's do it. Let me see how many colors I have here. Get this transformation done. Let's do the negative sign out front. We all know what that means. We've got to reflect this through the x-axis. So if you'd like to jump over your green, do that right now. Guys, reflect this through the x-axis. Please tell me that it looks something like this for that reflection. So this represents y is equal to negative sign stuck out front, log base 2x. Next, gotta be careful here. Negative x plus 8, we all know we've seen these transformations before. We'll first take out the negative sign there, factor out negative, and guys, rewrite this as that. And that negative sign now that I've caught inside here, I'm gonna take care of it right now, means reflect through the y-axis. So let's pick up the green graph, reflect it through the y-axis. Oh, if I reflect through the y-axis, is it on the other side of the y-axis? Over here at probably -1, and it looks like something like this. I think you guys will agree. And let that represent y is equal to, at this point, y is equal to about negative log base 2. Yeah, it's almost out, guys. Negative x. Hope you can see that. So far, so good? Now that takes care of that. Now I've got x subtract 8. Oh, it's getting a little crazy on me. X subtract 8 means what? Horizontally shifted 8 to the right. That light pink graph there. Shifted 8 to the right. If I do, this point right here at -1 is going to land where if I shifted 8 to the right? That's going to be 7 for sure. So let's go ahead and go out to 7. And mark that. As I shift, I also have to be aware of, I got to shift that vertical asymptote, which is right now at 0. That's the y-axis. So that y-axis now, with the horizontal shift of 8 to the right, it's going to be down here at 8. And we'll have a vertical asymptote here. That's my vertical asymptote. My y-axis also shifted 8 to the right. Guys, that should be enough. See if I get this correct, because it now looks something like this. This graph pulls over 8 to the right, horizontally. So you label this, guys, y is equal to, I got a negative sign out front, log base 2 negative x minus 8. That's what the purple graph represents. I hope. Now what's my last thing to do? What's my last transformation? Let's do what? A vertical shift down 3. Try this in, a vertical shift down. Now, I'm talking about the purple graph. The purple graph now must be vertically shifted down 3. This is where I would suggest, I'm at the end, at the final graph, I would suggest as you do this, definitely I know where this point right here is going to land. If I vertically shift it down 3, it's going to be down here at -3 for at least one point to work with. It's going to be down here somewhere here maybe. This point here, shift it down 3. Let's pick up the x and y intercepts on this final graph. Now this is key. Key. X-intercept, we know how to find it. You go back and set your function equal to 0. I'm going back to the original. Guys, it looks like this. So I set y, f of x equals 0, I have that, I made no mistake. Now I gotta solve this, and here I am gonna solve it. I'm gonna move the 3 over first, out of the way. Now I have this remaining on the right hand side. I see a negative sign that concerns me. If you multiply or divide by negative at this point, you make this -3. The negative sign on the right is gone, and you're left with this. Watch here. Trying to find x. Anyone tell me what would be wise to do next? Very good. Nope, I'm not gonna move the thing over to the other side. Be careful. I think you mentioned something being moved. No. Change it into an exponential. Tell me what it means from way back there. This means at this point, Isabel, help me out.
2 to the negative.
Absolutely. 2 raised to a -3 is equal to,
Negative x plus 8.
look at that, that's amazing. If that step right above there means the same thing she just gave me. And that I can deal with. That's what it means. So guys, this is 1/8, be careful. It's equal to -x plus 8. 2 raised to a -3 is the same as 1/8. To solve for x, I'm gonna move the x over to the other side, guys. And I'm gonna move the 1/8 over to the other side, the right. I'm just moving the terms around, trying to get x by itself. And if I have no mistake, x is equal to 8 subtract 1/8, you can use a common denominator, or I think it's gonna be 7 and 7/8. 8 subtract 1/8, is it? 7 and 7/8, awfully close to 8. That's my x-intercept. Circle there. So I got that. Now, by the way, I got this point to work with. Now I have 7 and 7/8. My goodness, 7 and 7/8 on the x-axis. Oh, it's up here, it's close to 8, I should say. It's right there. Very close to 8. The y-intercept, before I leave it, always, we find f at 0. Okay, so guys, if I go back and replace x by 0, it looks like this, negative log base 2. If I replace x by 0, I'm going to end up with 8. And of course, subtract 3. Now, can anyone tell me what's the log of 8 base 2? Just that part. I replaced x by 0, got 8 there. Log of 8 base 2 is 3. I got a negative sign preceding, so it's a -3. And then, of course, subtract 3 on the end, also 3's going on here. -6. There's my y-intercept. Therefore, I know the y-intercept is down here. Let me go down a little further. Y-intercept's down here at -6. There's my point we said earlier. There's my x-intercept. That should be enough to connect and get the final graph. I'm putting it in red here, guys. It looks something like this. When I connect. Do not let it touch that vertical asymptote at 8. And there's your final graph. Now, could we do that Wednesday? Could you graph one of these with all those transformations going on? Okay, so we got the graph done. Now, I point out to the 4 o'clock session. After you finish, sometimes there's ways to check math and sometimes not. Anyone tell me though on this one? Suppose I ask you to find the domain of the original purple function without the graph staring at you. How would you find its domain immediately? No graph, no graphing, just domain. Something we mentioned way back to make a connection here. Where was it? For log, this part must be what always? Greater than what? Zero. So that tells me translate over here, if I'm gonna find the domain of this without the graph, that negative x plus 8 must be this. This part right here. Based on the definition. Now to solve this, easily done. Divide and multiply by a negative, reverse my symbol. Guys, I got the domain being x is less than 8. We'll put this in integral notation, looks like that. And by the way, it looks like it is by the graph, that, to the left of 8. The domain is negative infinity up to 8. And that confirms the domain. Range is no problem. On that final graph, that's negative infinity to positive infinity. Nice. Are you guys appreciating this recap? Whew. Trying to get all chapter 4 done right now. Okay, I guess we got all this going on. I call that part 2, we did the graphing. And then I think I'm ready, let's see if I'm ready. For I am. Okay, guys. Woo! This is the best I'm gonna do for you. Get to the handout. I'm gonna follow the handout. I'll have Michael read some of these things, items from the handout. And we're gonna look at it. I can't look at all this. We're gonna look at some here and some on the back. And then, I think the back takes me all the way down into chapter 5. Now, I don't know whether I gave this to you guys earlier. Last week, maybe. Does it start out with property of logarithm section 4.5?
Yes.
Okay, and does it look something like that? Okay, so we got to start on this last week. Thank goodness. Now, here's where we're going to close it down. Make it nice for us here. Okay, guys. Chapter 4, call it quits here. Michael, would you please do me a favor? Turn to, I think it's on the back. Where it says solve an equation. I think there's lots of things to solve. Is there a part there where it says solve the equation? Section 4. Is there one that says solve the equations?
There's a couple. Section 4.6.
It's section 4.6. Now I had more. That's the reason I brought this in. It's not as many as I have here. It is, same thing? Okay. You guys want to look at some of these. And by the way, please tell me, at the bottom there is the introduction to chapter 5. That's where I want to go. Okay. Part 3, Michael? Hang on. All this done. One mark down well for you. Here we go. Part 3. Michael, tell me please, we're not gonna work all these. What's the first one asking for to solve?
Log base 5.
Log base 5.
X plus 6.
X plus 6.
Plus log base 5. X plus 2.
X plus 2
Equals 1.
equals 1. You guys watch carefully. What's in that chapter 4? You're gonna solve for X. What does this give you a hint as to what's going on here? 2 logs being added. Is that product property? So could I rewrite for step 1, the left-hand side as a product, use the product property, as log base 5 of x plus 6 times x plus 2 is equal to 1. That's step 1. It's product property. Now step 2, from tonight, can someone now tell me what that strange thing means? And drop log.
Equals to 0.
There you go, 5, there'll be more. 5 raised to the 1? Is it 5 raised to the 1? It's equal to this. Look at that. The word log is gone. You've translated what it means. Even from tonight. And now you're across the street trying to solve this. We're going to expand this thing out, guys. This is x squared plus 8x plus 12. Yes or no? That's a middle school problem now. Move that 5 over, have one side be a 0, you end up with x squared plus 8x plus 7. You subtract 5. 12 subtract 5. This thing will factor. Thank goodness. X plus 7, x plus 1. Middle school. Split this up. I'm now considering x to be a -7, or x is equal to a -1. So my solution set at this point is this. -7, -1. It's done. Use product property. Look how easy that was. This is the last thing they do in your chapter 7. That should solve a few equations. Now, there's an issue. Can someone tell me maybe what the issue would be before I leave this beautiful work? What's the issue? What did that middle school teacher many times ask you to do after you solved an equation back then? Check it. Check it. Now here's the problem. I may not do a full check. We'll see. But I should check. Well, -7, check. Here we go. That means if you go back and replace x by -7, guys, I see right here immediately in the first term, replacing x by -7, you get -7 plus 6, what's that, -1? And you cannot find the log of the negative number. This part right here must be greater than 0. So -7 is out immediately. Maybe -1 will check. Let me do a full check on -1. If I do a full check on -1, replace it by -1, this says log base 5, I'm replacing x by -1, -1 plus 6, plus log base 5, -1 plus 2, and that is a full check, it should give me a 1. This says log base 5 of 5. My second term, log base 5 of 1. Guys, what's a log of 5 base 5? 1. Isn't it 1? It's 1. Next term says now log of 1 base 5. 5 raised to what exponent will give you a 1? 0. This one checks. I did not do a full check on the other one because I saw a negative coming out early. That's what the answer is. Only -1. Michael, I don't want to run out of time here. Tell me maybe how many more, quite a few, right?
6 more.
Ooh. Michael, tell me the second one. Let me see if I want to do the second one.
Log base 4,
Log base 4,
x squared minus 9,
x squared minus 9,
minus log base 4,
minus log base 4,
x plus 3,
x plus 3
equals 3.
equals 3. Oh, this is going to be cute. Now guys, if you want to jump right into it, I see a subtraction sign. And that subtraction sign implies which property?
Why?
The quotient, division. So I could rewrite this as one single log, log base 4, and write it as a quotient. X squared subtract 9 over x plus 3 is equal to 3. Now that's quotient property. It looks like we left out here. I can sort of clean this up also. So I could rewrite this as log base 4. And guys, I think the numerator will factor difference of squares. No problem there. All over x plus 3, that's up to this X plus three will cancel, which is really nice. So it would clean up a little bit. Now, can someone tell me how you're gonna finish? How you gonna finish up now? You gotta tell me what it means. At this point, can anyone tell me what that means? Anyone?
For
For a cube.
equals X minus.
Thank you. That's exactly what it is. The log's gone. So guys, this is 64. X subtract 3, solve for x, add 3, we'll end up with 67. Now, I'm not gonna do a full check, you should actually check this. Aaron, if I went back to the original and checked 67, I'd have to square it. But I know also ahead of time, if you square 67, big number,
Positive.
subtract 9, will all that be positive? That we'll check for sure. And then down here, 67 plus 3, that's 70, right? Still positive. So I think I'm in good shape here without a full check on this one. Okay. Michael, do me a favor, if I'm running out of time here. Ooh, I'm trying to think of, jump down to the one that has like an e to the x or something like that. There's one on there.
E to the x
Yeah, is there an e to the x? Okay, e to the x.
minus e to the negative x
Okay.
equals 4.
Oh. Ah. Oh, this is the best one on, in that group, I think. Before I think, is there one on there where it says let u be something? They have on the side on it, okay, no. Okay, guys. This one has no log. No log is attached to this. Exponentials. Anyone tell me how would you start? You're sitting there taking the quiz, an exam, and you see that problem, and say, oh, there's no logs involved here, I can't use the property of logs. But what can you do?
You get ln.
Maybe an L a little bit later on, not right now. In the raw form you see right now, what would you do?
Divide.
Tell me again. So now we say divide where?
X.
Get close. Get close. This is an unusual problem. See, this is the calc textbook quite often. Anyone tell me, this is new for us, anyone tell me another way to express e to the negative x?
Long hop.
No, hold up, close. E to the negative x can also be expressed as 1 over e to the x. That helps some. Then what I'm gonna do, since we're out of time here, I would suggest now, I see an e to the x, I see an e to the x. You guys remember rewrite what we have here. We got, at this point, e to the x minus 1 over e to the x is equal to 4. I would suggest you just go ahead and multiply both sides by e to the x, try to get rid of that denominator. But I gotta be careful. So we'll multiply both sides by e to the x. I'll put it over here. And see what happens. Almost like a common denominator, but I'm multiplying through to get rid of something. Now, can anyone be careful? What's e to the x times e to the x? Be very careful. What give me? I know 2 responses, one is correct, the other is not. The students have given me in the past. E to the x times e to the x is equal to, I've heard in the past, e to the x squared. No, you're supposed to add the exponents. That's a property from middle school. So if I add the exponents here, this becomes e raised to the two x. When I reach this term, the e to the x's will cancel, which I like. Just multiply everything by e to the x. On the other side, not much to do there, it's 4 e to the x. Did we do all that correctly? This is the most challenging one, I think, in that group. The guys don't want me to make a mistake on this before we take a break. Okay, here we go. Gotta finish this up, and we'll take a break here. Anna, Art, watch carefully. You guys may have a different approach when you do it yourself, Anna and Bart. It's looking really crazy on me right now, but perhaps we solve this. Now, since we're out of time here, I've got to be careful. Guys, I'm gonna move that 4 e to the x over for a reason. You'll see the reason just shortly. And make it look like that. And Michael is probably gonna be the hardest one out of that group. E to the 2x minus 4 e to the x minus 1 is equal to 0. Michael, did I give it any hint at all on that problem? I didn't. I will if you saw one like this. I would say, please, after this, rewrite this. Let u be something. So you can rewrite it and make sense of it. What do you think the u would be equal to, like that u substitution we used way back? E to the x. So guys, it's e to the 2x becomes what if I let u, with Isabel's help? Squared here. E to the x will be x squared, u squared, minus 4u minus 1 is equal to 0. Who on earth, not me, who on earth would think this mess up here, this is the original, this mess, it turned into a quadratic. Now I'm gonna deal with it. And use, I was hoping this thing would factor. I don't think it's going to factor, is it? I'm going to use quadratic formula. So u is equal to, here goes guys, quadratic formula real quickly, 4 plus minus square root 16, subtract 4 times 1 times negative 1, I'm going to so quickly here, over 2. And this is for u. Quadratic formula. That's going to be 4 plus minus. Guys, underneath there is 16 plus 4, thank goodness it's not imaginary. 16 plus 4 is 20. Square root 20 simplified is what? 2 radical 5, I think, all over 2. I can simplify that, reduce it down by 2, and have 2 plus minus radical 5. Oh my goodness. That's everything reduced down by 2. Now, are you ready to turn your quiz in if you saw one like that? No, you're not finished. The original equation is in terms of x. They want x. We found u. We're not finished. What was u representing? Isabel says e to the x. I'm not finished. It says e to the x is equal to, now, it could be this, or separate it. It could be e to the x is equal to, the other one's 2 minus square root 5. Is that true? Now, one of those right now, before I solve and finish up and take a break, one of those right here in my logic makes no sense. One of these should be rejected right now, even before I jump in and try to solve.